What's up, mathematicians? Today we're talking about calculating percent change. We see real life examples of this all the time, probably every day without us even realizing it. Whether it's going shopping and seeing the price of something has gone from $20 to $15, you might ask yourself, what is the percent difference, the percent change, or the percent decrease? We might hear, let's say, a newscaster talk about the percent change in rainfall that a city or state has received. And it's mentioned so often. And frankly, it's one of my favorite things to calculate, if I'm going to be honest, because it's fun and it's interesting. And anyway, here is how we do it. Here is the formula for percent change. And it really is as simple as that. If you know this formula, you will be able to calculate the percentage of anything. How cool is that? Let's take a look at this. So percent change means either a percent increase or a percent decrease, or there could be no percent change at all, percent change of 0. And how do we calculate that? We calculate it by, we'll have a new value, and from that new value we subtract the original value, and then we do all of this first, and then we divide it by the original value. That will give us a number, and that number is often in a decimal number. Let's say it's 0.264 is our answer. I'm just making that up. From there, we need to convert the decimal to a percent. Now remember, a percent per 100 is out of 100. So really, we're looking at, remember, those first two decimals are out of 100, so this would be 26 out of 100. And what we want to do is we want to move this decimal point 2 spaces over, and that'll give us the percent. So this one would be 26.4% in our hypothetical example. So, and just to give you an explanation of why 0.264 equals 26.4%, if you have ever converted decimal numbers to expanded form, you would know that this 0.264 is the same as 2 out of 10, or 2 tenths, plus 6 100ths, plus 4 1,000ths. And when we add them, because we're dealing with percent, which means per 100, 2 tenths plus 6 100ths is the same as 20 hundredths, right? Because 2 tenths equals 20 hundredths, plus 6 100ths, which equals 26 100ths. And then we're going to add the, depending on how far you want to round the number to, we're going to add the 4 out of 1,000. Then we, remember, this is the percent that we're dealing with, so we get 26.4%. And whenever we could have a percent, to convert it back to just a plain old decimal, we would move that decimal point back, 0.264, and as you can see, this is, again, 4 out of 1,000. I hope I haven't lost you there, but I did just want to do that quick explanation of why percents make sense. That sounds funny. Percents make sense. Okay, anyway. Okay, let's try this formula with an actual example. This is from a worksheet that I gave my students. So, Sasha owns a clothing store. Last year, she sold a sweater for $40. This year, she wants to sell the sweater for $50. She wants to make more money, clearly. What is the percent change in the price of the sweater from last year to this year? So, we are going to plug in the percent change formula. Percent change equals new value minus original value. And sometimes you'll see this written different ways. You'll see like value, the second value minus the value 1 over the value 1. You'll see it in different ways. I tend to do new minus original over original. And when I was younger, I used to sometimes get this mixed up. I would sometimes put the new number down. And so I have this thing that I do now where I make this diagonal circle to make sure that the original and the original are the same. I don't know if that's helpful to you, but it helped me when I was younger. And so, yeah, so now we have the new value. The new value, Sasha wants to make it, let me make that a different color, purple, percent change. The new value that she wants to make it this year is $50. The old value is $40, and then we're going to divide that over 40. And then remember, we want to do everything on the top first. There should probably be parentheses there. So 50 minus 40 is 10. Then we've got 10 40ths. Now, what does 10 40ths equal? Well, it equals 1/4. Remember, we can cross out those zeros. And there are two ways now to get the percent answer. So I know that 1/4 equals 0.25. I know that from memory. Let's say I didn't know that from memory. I'd still know that 4 is a factor of 100. So I could do 4 times 25 times whatever I do to the bottom, I do the top, and then I get 25 that way. So that's another way of doing it. But let's say you don't remember any of those ways. Then you can go to the traditional way of converting a fraction to a decimal number, which is 1/4 is the same as 1. I always do 3. I always go 3 zeros out, 1.0 divided by 4. Always keep in mind that this fraction bar is the same, means the same as division. And now let's solve the problem. So we're going to line up our decimals. 4 goes into 10 2 times. 4 times 2 is 8. We ignore the decimal when we're subtracting, and we get 10 minus 8, which is 2. Bring down the 0. 4 goes into 25 times. 4 times 5 is 20. We're going to end up with 0. So our answer is 0.250, which is 25%. So back to the original problem. Sasha owns a clothing store. Last year she sold a sweater for $40, and this year she wants to sell it for $50. What is the percent change in the price from last year to this year? Well, it is 25%. An increase, we could even do a plus sign, an increase of 25%. Let's do another example. Last year, 12 streets were paved. This year, 10 streets were paved. I'm going to move this up a little. What is the percent change in the streets that were paved from last year to this year? Let's plug in the formula. Let's do green. So we've got percent change equals new value minus the original value over the original value. Let me make sure I put the right value in the denominator. Yes, I did. So that's going to mean it equals the new value, which is this year 10 streets were paved. The old value, last year 12 streets were paved. So we're doing this year minus last year because we're going in order of time, temporal order. So 10 minus 12, and then we're going to put 12 because these two numbers should always match over the original number. And now, this is very interesting. We get a negative number because 10 minus 12 is negative 2. And so whenever we have a negative value in our percent change calculation, it means it really reflects a percent decrease. So the percent change reflects a percent decrease. And we've got negative 2 over 12. And let's say I want to make my calculations as easy as possible. Well, I know negative 2 over 12 is the same as negative 1 over 6. And we can use even though I know what that is, I'm going to actually plug it in so that you guys can see me solve the problem as you would normally. So 6 goes into 10 one time. 6 times 1 is 6. I subtract 10 minus 6. Remember, we ignore this decimal when we're subtracting. Bring down the 0. 6 goes into 40 6 times. 6 times 6 is 36. Up, I'm going to get a repeating decimal, aren't I? 40. Yep, so it looks like it's, and we're going to have, remember this is a negative, so negative 0.166 is the decimal. And I usually have my students round to the nearest whole number percent. So this would actually be 16.6%, and I put that line over the 6 to indicate that the 6 doesn't, it's repeating. But we can just round this up to negative 17%. So to answer the question, it is a negative 17% change or a 17% decrease, because we've got that negative number. So there was a decrease of 17%, a decrease in the streets paved from this year to last year is a decrease of 17%. I hope I said that okay. Sometimes I make so many of these videos, I get lost, and even what I'm talking about, and I know I can talk fast sometimes, so I do apologize for that, kids. All right, let's do one more. Let's do one more, just for kicks. Okay, so a florist sold 25 tulips last month and 30 this month. What's the percent change? Remember, we're going from this month to last month. Many percent change problems will involve time, a certain time to a certain time. Let's plug in the formula. So percent change equals new minus original over original. And you can see I'm writing it all out again because I want to make sure that this gets cemented in for you. I'm going to circle that. Okay, what's the new value? So it equals, the new value is 30 this month, 30 tulips sold this month, 25 last month. And we're going to put it over the original value, which is 25. We're going to get 5 over 25. Now, one straightforward way to convert 5 over 25 to a percent is, remember 25 is a factor of 100 multiplied by, actually I'm going to do that in a different color. 25 times 4 is 100, 5 times 4 is 20. So we are talking about a 20% change, and it would be an increase because these are positive numbers. So a florist had a 20% increase in the amount of tulips they sold from last month to this month. And it's really interesting, and the percents are interesting because you can see here they sold 5 more tulips. It doesn't seem like a lot, but a 20% increase kind of puts that into perspective. 20% increase seems like a substantial increase for how many tulips you sell. I don't know, to me it does. As with many mathematical formulas and learning new concepts, practice makes progress. So we do a lot of practice with this, and eventually it just becomes second nature. It becomes automatic, calculating a percent increase or decrease or change. And that is all for today. Till next time.